Hey everyone. So tonight I'm going to quickly talk about JavaScript mapping. The whole purpose of tonight is to give you a good idea of the nouns and the deep, delicate vanilla voice. Okay, so next 10 minutes I'm going to be showing you, hit the start button please. A quick round trip of the nouns and the various things that if you're a web developer or a developer in general and you have to show something, the things that you're going to expect to run into. What they are, their strengths and weaknesses, and then hopefully questions. All right, quick thing about me. Software developer, I currently work at EQ Works, which is a company down in Bay and Bloor. Before becoming a software developer, I did a lot of mapping out in the oil sands. Lots of army before that. Yes. Oh, what? So I'm going to be talking about all these major players, their strengths and weaknesses. They're all not the same things. They don't operate some of the same spaces. Sometimes they overlap. So the first one is Openstreetmap. It's the Wikipedia of maps. This is generally a source that a lot of people in the JavaScript web mapping universe use. But otherwise, when you run into it, you can use it as a source. If you want to make edits on it because there's something that's not on Google Maps, usually you can use this, and it'll also translate a lot quickly into the maps in the map layers that use OpenStreetMap as a source. Lovely thing about this is also if there's a humanitarian disaster, there are teams of mappers that actually assemble and make maps of places which don't actually have the civil society to make the maps to help international teams rescue as many people as possible. This is something that the Canadian Forces actually used in Tibet during the earthquake to great effect. So if you ever have a bit of time during a disaster, look up these guys, ask me about it after. Leaflet. This is a beginner-friendly Slippy map library. It's used in JavaScript. There's a lot of base maps that you can choose from in the universe. This thing is compatible with tiles or Mapbox vector tiles. I'll get into that in a little. But the big strengths of this is that if you need something now, quick, and you don't want to do a lot with it, this is the first library you generally reach out to. It's open source, so if you want to make changes to it, you can. Mapbox. Mapbox was actually created, the JavaScript libraries for mapping and Mapbox were made by the same dude who started Leaflet, but the only difference is that this does so much more. But not only that, but it also has spread out into many other aspects. You can store data that can be displayed on base maps. You can do some crazy heat maps and data visualizations with the actual mapping technology they have. Uber has gotten to a real big partnership. These guys actually want to be the maps on every autonomous vehicle or every vehicle that you drive in as well. They have some analysis tools. They have a fantastic directions API. So if you don't want to use Google Maps, these guys are definitely a guy that you want to look up to. So they do great, again, for Slippy maps, and then some static maps as well. Oh, and they also have gotten into games as well, if you like Blender. And what's that other game thing that people use? Unity, yes. They have a fantastic Unity and iOS SDK as well. Esri. If you are in the public sector or the educational sector, you're going to run into these guys. These guys did GIS analysis back in the day when computers were in their young stages for the command line. They run everything. They've got analysis software like some JavaScript map. They've had JavaScript mapping libraries back in the day of Dojo, if people remember that. They've got also an army consultants. If you're a startup, you probably don't want to be walking down this, but if you're in the public sector or the education sector, these are the guys, and they have fantastic documents and a fantastic community, and a lot of people who drink the Kool-Aid with these guys, and their own set of base map services. It's a closed ecosystem. Next one, Google Maps. Hands up for here who has not heard of Google Maps before. You're lying. Okay, so they're very, very closed. They want you to use everything within their area, but they also have, well, the first and probably still one of the best sources of base map data, as well as location API, as well as a good idea of where everything is. It's still, I have to admit, in some places it's better than OpenStreetMap, but it is not, in the Canadian experience, it is not exhaustive. For a good example of this one is that I actually had to meet my boss, like one of my oil sands mapping jobs at his home in Grand Prairie. But the problem was that Google Maps in 2015 didn't map the developments out there, so I was lost and I was late by 3 hours. So if you're up in the more remote areas of Canada, OpenStreetMap actually might be or OpenStreetMap derived services may be a better example than Google Maps, but in urban areas, they are still the best. Also, their API docs are hard to get to if you're not already a customer. You have to sign on if you want access to their Google Maps API docs, I find. You can't just Google it. Open layers. You're going to run into this. This is one that I considered a write-off, especially when Leaflet and Mapbox came out. They're a Slippy Map JavaScript mapping library, but they're also one of the first. They're part of the Open Geographic Consortium suite of products, purely open source, even before the days of GitHub. But they're really, really good if you actually have to use base map services, like services that you don't understand the acronyms for because they are archaic, like Web Map Service, WMS. The big thing, though, is that they've just had a major update. They brought their stuff to GitHub. They're not dead yet, and they can be used. So if you actually are still using these, they can be brought and they can be upgraded still in the same ecosystem. D3. Now, a lot of people, when they think D3, they think that this is great for infographics, but they don't think about maps. Well, D3 is great for one particular type of map, static maps specifically. They do things in different projections. I'm at 6 minutes. This is great. What's a projection? Well, the truth is that the truth is this. When people think or ask me the question, what is the shape of the world? A projection itself first is our guess, 2D representation of the shape of the world. But the shape of the world is so messed. It's not a circle. It's not a sphere. It's not an ovoid. It is a shape that is so funnily messed up that we've given up and given it its own name called the geoid. So we actually use so there's a plethora of coordinate systems as well as two-dimensional interpretations called projections. And D3 does a whole lot of these. Every other web map service or every other JavaScript web mapping library does one, Web Mercator. EPSG 3587 based on the WGS 1984 projection. You don't need to know these to be an excellent JavaScript web mapper, but if they want something in a different projection, and they don't care that it's slippy or it does anything, they just want a static map right now, this is the guy you want to reach out for. Sorry. Finally, the last two things I'm going to talk are more in the analysis area. There are two major, if you actually want to do real-time analysis, like if you want, for example, to figure out in JavaScript, in the browser, if someone puts a series of dots, where's the center? If they put 2 dots, what is the run line or what is the bearing? There are 2 libraries. The first one is turf.js. This is an open source JavaScript library and is fantastic. One of the chief maintainers is actually in Ottawa, so it's, I guess, a Canadian success story. But these guys, the idea is that this is browser as well as node-based analysis. If you can't reach for a database, this is a great API, or this is a great tool to reach out for. Last but not least, PostGIS. I actually have a T-shirt that says Postgres is my database. Unfortunately, it's hard to read because it's blue and black, but point being is PostGIS, this used to be just like the standalone extension, but it's now part of it's very close to the core library that most installs of Postgres actually include this so that you can just enable the extension without installing any extra software. This is probably the best tool out there in the geographic world that's free for like analysis of hundreds of thousands of things at once. And truly, if you ever have to do analysis, the best place to do it is always at the database layer. You can do some really, really crazy stuff, and you can do it in milliseconds with this. That would take maybe halves of seconds in the last one, Chirf. So that's pretty much the little tour, the nouns, a series of nouns, and the best nouns out there if you ever actually run into this world. If you have any questions about these, I can be approached. I hang around and lurk on Trono.js as well as the Polyhack Slack channels. Poly Slack. But yeah, so I'm going to open the floor for questions. Thanks. Go.
What's Slippy?
Slippy. So if you click on the map and you click and drag, it's sort of a way of saying that it slips around. Question.
Actually, as a comment, I just want to note that Openstreetmap has some pretty decent tools for reverse geocoding and also feature search.
They have, yes, they do have the nominatum.
Yeah.
You do a lot of OpenStreetMap yourself?
I've done a fair.
Cool.
Can you repeat what he said?
So the question itself was that, or the observation itself was that you can actually do some basic analysis, geocoding, that is finding addresses from lats and longs, and the opposite, using the OpenStreetMap itself through their nominatum. I don't know how to pronounce that engine. Nominatum. Other questions? We got other questions? All right. You had a question.
It was the same question.
Yes.
A long time ago, people used this thing called geohashing.
Geohashing.
People do anymore? Is that a thing still?
You're referring to an old XKCD comic, right?
No.
Oh.
I mean, maybe it came from the original. I'm not sure. So the idea is, we've got a lat and a long. You don't always want two pieces of data that could get separated or lost. How do we combine them together into a single piece of data that we can use? Well, we can hash them by interleaving bits from the lat and the long into a single thing. And then people actually use this as like a tag, for example. So like you put an anchor tag and then the geo hash of the address, and then eat that and find the location.
It's like a space filling quadrant.
Yeah.
So,
A very simplistic one.
I believe people still do that, but not at the level of JavaScript web mapping, and even at the database when you store. Maybe once they're actually stored in the PostGIS database, and at that level, yes. But as far as the web developer side of the stack, I haven't run into geohashing.
Okay. One of the nice things about it is that as you add more bits to it or more characters, it gets more specific. So if you use it as an anchor tag, for example, you could have a very long one that's very specific, or you could truncate it and give something more general,
Okay.
which is a nice attribute.
Cool. Yes.
So if I want to make like a star map or something like that, or make my own type of custom map, would I be able to use any of these?
A custom map?
Yeah.
So,
With my own tiles that don't necessarily align with like real world locations.
yes, the stipulation is that you'll have to use a system that assumes a 360-degree sphere,
Yeah.
or something very, very close to that with edges. There's ways to work around with that. People have made fictional maps using Leaflet as well as Mapbox.gl. But the trick is that you are going to also have to populate the base layer. There are services that actually do that I have not talked about. A couple of these worth looking into are Mapnik, Tagola. These are things that actually take in data from various sources and then project things like Mapbox vector tiles, or even just the old school raster 256 by 256 PNGs. That's the dimensions of the pixels, I should say. There are ways to do it, but it's not easy compared to just taking the data that already exists and plopping it onto a map. Other questions?
Do any of these services give you access to three-dimensional data about building size, for example?
So do any of these services give you access to three-dimensional data, including building size? The answer to that one is yes. So that actually happened probably in the last 3 years. What happened was that there was a tremendous leap where web mapping services started to use WebGL. And they started to looking at extrusions. Google Maps, of all the people, Google Earth led the way in that one. But then some people looked at this data and said, what if we use other stuff for the Z-axis as well, like vote share, it's an election tonight, or even just the year of the building. So they're a good example. I have made actual several maps that are based on StatsCan data using the Mapbox.gl library. that do have a hokey. It's almost like 2.5 dimensions, but the gaming SDKs in Mapbox have more fine control.
Okay. So you can actually get that data from their API.
You can get their data, or you can actually import their data as your own data as well. Importing and using your own data, especially with Mapbox in the open source world, or Leaflet, not so much Leaflet, but it's always an option.
Right. So you could take your data for like voter share, for example, and you could take their data of building dimensions, and then fill up the building with, I don't know, red and blue or whatever. What are the colors here?
Red, green, blue, orange, purple, all the Lucky Charms.
Yeah.
Yes, the answer to that one is yes and more.
Cool.
All right, we're at 15 minutes.